All right, welcome back. Um, so the other night we had a little technical difficulty, so this is part two of the pre-test video that I'm making. I'm gonna try to finish this one fairly quickly. Let's start with this one. This is a bike shop owner bought 18 bikes and 16 trikes for $4,110 or what $4,100.10. He found he had under ordered, so he placed another order for 12 bikes and 8 trikes for $2,591.40. Find the price for an individual bicycle and an individual tricycle. Define any variables you use and show all your work. All right, so this is a little bit different than the ones we've been doing in class, but not too different. So I'm gonna put this off to the side. All right, oops, I got a piece of paper already. And I'm gonna use Miss Kafarkas's pen. I stole it from her today. Thank you, Miss Kafarkas. Okay, so I have a bike. I'm gonna call that X, and a trike. I'm gonna call that Y. And I'm gonna set up my first equation for my system. So he bought 18 bikes. So 18 bikes and 16 trikes. And all together he spent $4,100.10. So there's our first equation. And then our second equation is he bought 12 bikes and 8 trikes, and he spent $2,591.40. Okay, so we have our system. Now we're just gonna figure out the best way to solve it. So I think the best way to solve this is, well, there's a couple ways. We can use elimination, where we manipulate one of these and then combine them so that one of the variables cancels. So that's our first option. We could solve it for y and then set them equal to each other, and then we could check it with a calculator. So I'll do both. So let's see if I can split this. Just like that. And you know what? Yeah, I'll do it with a marker because I came across kind of sloppy. Okay, there we go. Okay, so on this side, I'm gonna call this equation 1, and equation 2. Okay. So I'll call this substitution. I hope I spelled that correctly. Let's see how to spell that guy. Substitution. Oh, look, I did spell it correctly. Substitution. Look at you. Substitution, or we can call that like setting equal. And then over on this side, I'm going to call this elimination or combination. And you can use whichever method you prefer. If you use this method, you can check it with the calculator. So let's start with that one. So for that to work, I'm going to take both of these equations and solve them for y. So for equation 1, I'm going to subtract 18x and move it to this side of my equation. So I'll have this 16 times y equals 4,110 cents minus 18x. And then I'm just going to divide both sides by 16. Right, and that would cancel to 1y. And then I'm going to end up with this. So I can say that y equals this divided by 16. So that's our equation 1. And then equation 2 is going to be the same idea. So I'm going to subtract this 12x to this side and then divide by 8. So I would have 8y equals 2,591 $91.40 minus 12x. And then I'm going to divide both sides by 8. And you have that. Okay, so there's our two equations. So this is y equals, this is y equals. At this point, I could take them algebraically and substitute this in here for this. It'd be a little messy, but definitely doable. What I think I'll do instead is, in a minute, I'll graph this to find the solution. But in the meantime, I'm going to use the elimination and combination method, and then let's make it not like that. Let's try this. There we go. Give me a sec. This guy's having trouble focusing. Okay. There we go. Now hopefully it won't be, it's still bouncing around. Oops. That's Muffin upstairs sneezing. Alright. Now let's see how that looks. Okay, so now hopefully it's not struggling to focus, although it still looks like it is. So sorry about that. All right, so elimination. I'm gonna take one of these and manipulate it and hopefully eliminate one of the variables. So there's lots of ways you could do it, but what I'm gonna do is I'm gonna take the second equation, equation 2, and I'm gonna multiply all of it times -2. Oh, it's Bernie. Coming over to his dog bed. Okay, so if I took equation 2, so I have 12x plus 8y equals this, I'm going to multiply all of it times -2. Right? I think you'd probably actually want like parentheses on both sides, but okay, so -2 times 12x is -24x. -2 times 8y is -16y. Oops. -2 times $2,591.40. Alexa, stop. Is $5,182.80. Hold on. Time to give the old dog his medicine. All right. All right, sorry about that. Okay, so by doing that, now I have -16y. So this is equation 2. When I combine it with equation 1, which is this, I'm essentially thinking of this as like a giant addition problem. And I'm going to combine all of these. And the point of doing that is this and this will cancel. So -24x plus 18x is -6x. This goes to 0, this cancels. And then this plus this will become this. And then the final step is just to divide by -6. There we go. You guys can see that. I don't know why it's having trouble focusing. Okay, but I'm going to take that and divide it by negative 6, and I get 180.45. So that means that 1x is equal to 180.45. Well, what does that mean exactly? Well, if you go back to the very start, we said bike. The bike was represented by x. So that means the cost of a bike is $180.45. So now we need to find the cost of what a trike is. If it's me, I'm just going to take this and I'm going to plug it in to either one of these and solve it for what y is. So here, I'll do that on a second piece of paper. Lots of paper here. Okay. So I'm gonna choose to plug into equation 2, but if we do it correctly, it shouldn't make a difference. So instead of 12x, I'm gonna say when x is equal to 180.45 plus 8y equals that. If I distribute that, 12 times 180.45 is $2,165.40. Now it's just a two-step equation. I'm going to subtract this. And I'm going to subtract this. Oh, look at Muffin's making another cameo in the video. Come on down, Muffin. No one can see you, honey. You look beautiful. Alright. That gives you 8 times what I say. Hi, Muffin.
Hello.
There you go. She's wearing an evening dress. You can't see it. This minus this is 426. And I'm just going to divide that by 8. Oh, there you go. 53.25. The cost of a trike is 53.25. All right. So if you go back, that's a lot of work. That's a lot of work. If you go back to this, I'm going to enter these two and kind of check our work. Muffin's going to sit in the audience and listen because she loves systems of equations. All right, so the first equation, put in parentheses, y equals this minus that divided by 16. All right, and then our second equation is this minus that divided by 8, and I'm going to graph it. Okay, I've zoomed out enough already so you can see it, but it might start, right, just so we can see it. It might start with some window where you can't see it. This is like the standard viewing window. Well, I'm going to take it, and I'm going to zoom out, hit enter. Oh, still nothing. When it gets done thinking, I'll zoom out again. Zoom out, hit enter. Oh, okay, I can start to see it up here, but not really always. So I'm going to zoom out one more time. And then I can see it. Okay, perfect. Now I'm hit second calculate, and I'm going to hit intersection. And hit enter, enter, enter. And there's an intersection, just like our combination method proved. So there you go. That's that big system of equation question you're going to come across on this test. No problem. There it is. All right, next one. Number 25. Solve for x. Negative 3 times x minus 4 is less than or equal to 9 plus x. If this was me and I'm doing this, I'm definitely going to distribute first. So let me write that on a bigger piece of paper. All right. And you know what? I don't know if I've shown this previously, but I'm gonna do this 2 times so we can see. There's a rule that we use, and maybe this will help illustrate it. So I have negative 3 times x minus 4 less than or equal to 9 plus x, and I have the same thing here. Minus 4 less than or equal to 9 plus x. Okay, so I'm going to distribute first. I'm going to have negative 3x plus 12 less than or equal to 9 plus x. And I'll do the same thing here. Negative 3x plus 12 less than or equal to 9 plus x. And on this side, I'm going to move my x's here, and on this side, I'll move my x's to this side. So I'm going to add 3x, and I'm going to add 3x. So that leaves me 12 is less than or equal to 9 plus 4x. And then I'm going to subtract 9 from both sides, and I get 3 is less than or equal to 4x. And then I'm going to divide it by 4. So I can say that 3/4 is less than or equal to x. Okay, whoops, there you go, now I can see it. So there's one of them. So I'm gonna do the same thing here, but this time I move my x's to this side. So I'm gonna start by subtracting x, so I have negative 4x plus 12 is less than or equal to 9. And I'm gonna subtract 12 from both sides. Negative 4x is less than or equal to negative 3. And then finally I'm going to divide by negative 4. And that would give me x is less than or equal to 3/4, right? Because the negatives would cancel. Okay, so we have a problem. At the same time, how can x be greater than or equal to 3/4 and less than or equal to 3/4? Well, it can. And the problem was this step here. So if we take an inequality and we divide or multiply on both sides of the inequality symbol, then we have to flip it to keep it working. We don't have to do it with an equation. That's really the only key difference. So this is not correct because I have to take it, since I did this here, this symbol has to flip to that to make it still be true. I hope that helps show the reason. But just remember, if I divide or multiply across an inequality by a negative, I have to flip the symbol. So what answer was that? That was 25. That was this guy here. Perfect. Okay, 26. The table shows x and y values for a quadratic function. Based on the table, which of the following statements is not true? I just drew a quick sketch of this. -1 and -7. 0 and -1, 1 and 1, 2 and -1, 3 and -7. Well, this definitely opens downward. Well, if I just read the first option, it opens upward. Okay. It's not multiple, it's just a single answer. So, A, you can stop working. Next question, 27. The surface area of a right circular cylinder with height h and radius r is given by the formula S equals 2 pi r squared. Alright, S equals 2 pi r squared plus 2 pi r h. They're saying which of the equations gives h for a right circular cylinder with a surface area of 54. Well, okay, so 54 equals all of this, right? That's what the surface area represents. And essentially, they want us to solve it for h. So I want to, at the end, I'm going to get that h all by itself. So I'm going to start by subtracting all of this from both sides. All right, so I'm going to subtract this. I'm going to do the same thing here. So now I have 54 minus 2 pi r squared equals 2 pi r h. Sorry, that's an h. Hang on. And then my final step is just going to be divide by 2 pi r. I'm going to do the same thing here. Okay, so then I have 54 minus 2 pi r squared divided by 2 pi r equals h. Well, I don't see it as one of our answer choices. And the reason is I can simplify it. I can divide all these by this 2. So that would leave me 27 minus pi r squared over pi times radius. That is all equal to h. And that is C. Once again, not so bad. All right, 28. I've already circled some of these because I did it already and I had to remake the video. Ben is studying how the number of bacteria in a dish changes over time. He determines the initial number of bacteria in the dish is 640 and the number of bacteria doubles at the end of each hour. Which function, f of t, can Ben use to determine the number of bacteria in the dish after t hours? So f of t equals, all right, well, 640 plus 2t. This is going to be a linear function, right? I said a way that might help to think about it is I could think of, right, like f of t, I'm sorry, and, I'm sorry, I'll do maybe like this instead. I could think of t and f of t, there you go. So at 0, it starts at 640. If this is confusing, you just think of this as x and y, right? You can make this like, right, y and x, if that helps kind of unconfuse you. I know it's gonna be doubling each hour. So after 1 hour, it should have 1280. After 2 hours, it should have 2560. That's about all I'm good for. I've got to bust out the calculator. 1280 times 2. Okay, after 3 hours, it's going to be 5,120. 4 hours, it's going to be 10,240. So on and so on. So on and so forth. Excuse me. Okay, so I know basically if I plug one of these numbers, and this seems to make sense to me. If I plug 3 into one of these functions, I should get this. That's one way to do this, right? Like on the algebra test, just plug stuff in that you know makes sense and see if it works. Well, if I plug 3 into this is going to be 640 plus 6. This is just a linear function that's increasing with a slope of 2. So it's not that. 640 times 2 times 2. This is just 640 times 6. Well, 640 times 6 is definitely not 5120. So that's not it either. So I can kind of go through, oh, no, not that one. I can try this one, but this is going to get smaller and smaller, right? This is going to decrease over time. If I plug the numbers in here, that's what it is. This is 640 times a doubling of each time, so it's this guy. Or another way to think about it is, this is the growth factor, and this is the start. So the answer is D. Okay, next question, 29. Once again, I circled this guy because I made a previous video and I didn't record it. Okay, Sandra buys 3 notebooks, 5 pens. Hector buys 2 of the same and 6 of the same pens for $9.58. Don't go solving it, just call one X and one Y and see which one makes sense. Okay, this first one is saying the number of notebooks, if I called the notebooks X and the pens Y, but you could flip it doesn't really matter. I said the amount of notebooks, this is saying the amount of notebooks plus the amount of pens equals 1047, and that's not it. This would be like X plus Y equals 8 if we were really doing it. This one's way off. This person has an idea, but you can see they confused. Sandra bought 3 notebooks and Hector bought 2 notebooks, but they've kind of confused, like, okay, this is Sandra and Hector, and no, this is Sandra and this is Hector, so this does not work. So it's gotta be this. This is Sandra's 3 notebooks and 5 pens. This is Hector's 2 same notebooks and 6 pens. So it's C. Okay. Number 30. Suppose a baseball player hits a ball in the air. After 2 seconds, the height in which the ball is modeled by h of t equals, I'll get a piece of paper for this guy, equals negative 4.9 t squared, plus 30t plus 1.4. All right, so I'll write it a couple ways. I got h of t equals negative 4.9 t squared plus 30t plus 1.4. I said I tell my students, if the function notation on this test confuses you, you can always just rewrite it with y's and x's. If that helps. If it doesn't, use it. It's something you're gonna have to get used to, but for this, don't want to confuse you. Okay. So when I look at this, I have a downward facing parabola that has a y-intercept of 1.4. So I'll schedule a guy up here. Okay, so I'm gonna have something like this. It's gonna start, maybe I'll do that in brown. Okay, it's gonna start right there. So it's gonna go something like this. Okay, down here, I don't know, we'll graph it so I can see exactly how it looks, but we're really only concerned about this. This is only like, this is like the real world application that we're looking at. So this is like the height of the baseball player hitting the ball, and this is it hitting the ground in the outfield. Okay. So I think with all of these, drawing a little picture and stopping and thinking for a second can be helpful. So this is like the 0.0 and 1.4. So that's like the height of the batter. I'm not going to try to draw this. That's the head of the batter. He swings, he hits the baseball. We're not concerned about like this. This is time. And this is like our elevation. And he hits the baseball and it comes down. So then they ask some questions. Which finds the best interpretation of h of 2 within this context? So basically they're saying h of 2 is like going to be this here, whatever that is. So let's see, so this is something that the calculator on the table can be helpful. So a little sketch kind of just maybe will help us make sense of it, because sometimes the calculator doesn't graph it as nice and neat as I just did. So y equals negative 4.9x squared plus 30x plus 1.4. Okay, I'm going to graph it. It's going to be really tiny because I'm still zoomed out from that tricycles question. But let's zoom standard. Okay, so this is clearly like a different zoom. The max is, I can't even see the max there. But I can maybe hit the value. So let's see the value of 2. Okay. So basically what this is telling us is at 2 seconds, the ball's 41.8 feet in the air. So that's what I would, let's see our options. Excuse me. There it is. Okay. I mean, this sounds reasonable, but let's look at the other ones and see why it's not. So after 41.8 seconds, the ball is 2 meters high. I mean, on its face, that seems kind of ridiculous, but especially since when they're saying h of 2, that they're saying when I input 2 into this function, what's the output? And that's this point here. This is, right, 2 and 41. 0.8, that's what h of 2 is. The ball reaches its maximum height at 2 seconds. Focus guy, there we go. I don't even know if that's true. We could find it, but that's not something they're really asking. The ball travels at 41 meters per second. I mean, that might be true, but that's a lot of work. It's definitely this. At 2 seconds, the ball's 41.8 meters high. There's a lot of these questions on the test. If you just kind of draw a sketch and take a second, it's not so bad. All right, number 31. Tony deposited $100 into a bank, and the amount in her bank account increases by 5% each year. And a number from maximum onto each of the blanks in the formula for f of x with the resulting function correctly represents Tony's situation. Okay. So I talked about this earlier. This is an exponential function, and we need 2 things. We need the starting value. That's our y-intercept. there's a nan there, starting value. And then I need a growth factor. Okay, well they already said that she starts with $100. So that's gonna be here. There's $100. And then the growth factor, for any of these like percentage ones, I always think of it as like it's 100%, like the balance plus the 5%, which is 105%. But we don't want it written as a percent. We want to convert that to like a rate, I guess. So, right, that's 1.05 for our growth factor. And if you're not sure, just plug in, like I said, make a table like we discussed earlier. Right, X and Y are, this is like time and money. And this is 0 and 100. Well, if it increases by 5%, and that's how much she should have. If I plug 1 in, the 105 makes sense. For 2, I'm gonna have to do a little work, but it's $110.25. Right, and this seems to make sense. This is 5% added, 5% of this. If I try anything else, it's not gonna work. Okay. 32, the function h of x equals 20, where it's the cost of a dinner at a restaurant for a group of x people. The dinner can only be held if at least 10 people show up. The restaurant can seat a maximum of 40 people. Okay. So in this case, this is like a domain and range question. I could really think of it also as like y equals 25x. Y is the money, like the bill, and X is the amount of diners. We're paying $25 a piece. They won't do it if 10 people don't show up. And the restaurant can seat a maximum of 40 people. Okay. So domain is, what can X be? Right? And this isn't a range question, but if there's a range question in the test, that just means what can Y be? So if I think about it, what numbers can I put in for the amount of diners? Right? These are like the monetary values. This is like a range here. But the domain is just what can I input into this thing realistically? Okay, so even if I just eliminate these 2 bad answers, I'm down to 50-50. Okay, so now I think of the set of real numbers, x, or the set of integers, x, such that x is less than or equal to 40 and greater than or equal to 10. So an integer is just a whole number, and the real numbers are like all, it could be 28.653 or something. Well, that doesn't really make sense if we're talking about diners, right? It's just going to be, they're not setting parts of diners to pay the bill. So it's just the integers, the whole numbers. But I said, even if you just got to that and you guessed, you're 50-50. 33. Examine the 2 quadratic functions shown below. So they give you a quadratic, they give you an equation, and they give you a parabola, g of x and f of x. What statement is true about f of x and g of x? If this is me, I'm going to graph them and see. Or even if you just graph g of x. I'm going to move it here so I can see. Okay. You could graph them together, or you could have one on here and one on here. I'll graph them on here, both together. So I'll do g of x first. This is x squared minus 2x minus whatever. And actually that's all I could do because they don't give you the second one. I could figure it out, but we're not going to. All right, I'm going to zoom out once. Okay, there's our parabola. Okay, the minimum of f of x. Let me slide this all over so you can see this. And you can see that. Okay, I think that'll work. Okay. So the minimum of f of x is to be a little less than -2. And the minimum of g of x looks to be -24. So the minimum value of fx is definitely not less than the minimum value of g of x. So no. Alright, I can see that. This is, I made 24, 25, somewhere in there, but it's much lower than -2, so it's not that one. The minimum value of f of x is equal to the minimum value of g of x. Like once again, we just discussed that. This minimum value is around -2. This is at least -24, so not that one either. The minimum value of f of x is greater than the minimum value of g of x. Yeah, that's it. -2 is greater than -24.9, whatever. Okay, easy. These quadratic ones are easy once you let the calculator do the work. 34, which of the following points is not a solution to the system? If I get this, there's a couple ways you could do it. You could solve it for y and then graph it and shade it and all of that. But if it's me, I'm just going to plug some numbers in and see which is true. All right, so if I think about plugging 4 and 3 into this first equation, all right, and this is like a little bit of scratch paper for this one. Okay, so x is 4, so is 4 less than 3 times 3 minus 3? Well, that's 9 minus 6. Okay, yeah, that does work for equation 1. 4 and 3 do work. 4 and 3 do work for this one, so let's see if it works for this one. If I put 4 and 3 in here, 5 times 4, all right, I'm just saying like 4 and 3, I'm taking this 4 and plugging it in there, and this 3 and plugging it in there, and evaluating if this is true. All right, well 5 times 4 is 20. 2 times 3 is 6. 20 minus 6 is 14. 14 is greater than or equal to 11, so that is a solution. So yes, that's a solution, but they're looking for not a solution. So let's try the next set of numbers, 4 and 4. If I put 4 here, 4 is less than 12. Yes, that's 9. 4 is less than 9, and here that'd be 20 minus 8. That's 12, 12, that still works. Okay, 3 and 4 is 3 less than 3 times 4 is 12. 12 minus 3 is 9. Yeah, so 3 and 4 work for this first one. How about here? What is 5 times 3? 15. 15 minus 8, right? 2 times 4 is 8. 15 minus 8 is 7. 7 is not greater than or equal to 11. So this is not a solution for both. So that's the answer. All right, don't even worry about the fourth one. I mean, when you have time at the end, you can go back and double check that, but I'm looking for not a solution. That's what I would do. All right, 35, cranking along here. The population study is modeled by the function below, where t is time. Based on, like I said, if you don't like this, Mr. Gerard, I hate function notation. Okay, well, I'm going to rewrite this function. This is just, and you know, if I don't like this 10 to the 6th, where is it at? There you go. If this is throwing me off, I can just write it out for what it is, right? 10 to the 6th is, oops. 1, 2, 3, 4, 5, 6. That's just a million. So I can rewrite it like this if I wanted, if this helps. Y equals 1 million times 1.08 to the power of x. Right? It's the same thing. And P of t is just my population. So P of t is my population, and t is the amount of years or years. Okay. So the population is increasing by 0.08 each year, or the population is increasing by 8%. The population is increasing by 1.08, or the population is increasing by 108% each year. I mean, I said it, the way I think about it is, this 1.08 is, if I turn that into a percent, it's got the 100% and it's growing this 8%, right? Like with the other question, so it's 108, which is 100 plus the 8%. So it's B. We're about 8%. All right. What is the y-intercept line that passes to the point -8, 7, and it's perpendicular to the line y equals 2x plus 5. Okay, this is something we kind of cover, but it might or might not be on the test. All I have to remember is, so a perpendicular line is a line that makes a right angle, and the way that you could think about it is like if this has a slope of, I don't know, 2/5, this guy right here, then this slope, if it's perpendicular, would have a slope of -5/2. So it's just going to be the opposite sign, right? Which makes sense because they're going to be crossing like this, and then it's the reciprocal with the opposite sign. So what's the direction of the line that passes the point -8, 7 and is perpendicular? So it's going to be perpendicular to this. So I can start with that right there. So it's going to, this is like 2/1. It's going to be -1/2 x, right? Because for this new line to be perpendicular to this one, it has to be the opposite sign and the reciprocal. And they're looking for this plus b. Well, I know it passes through here. So this is a solution. So I can plug these values in and then solve this for this. So that's what I'm going to do. So I'm going to say 7 is equal to -1/2 times -8 plus b. Well, this is 8/2, so 7 equals 8/2, which is just 4. Plus b, well, b is 3. Easy enough. All right, so 37. Okay, this one's a little tricky. I don't know if they'll have anything on test this tricky this year, but focus, there we go. The length of the short side of our triangle is 11 inches. The lengths of the other two sides are represented by consecutive integers, so two numbers back to back. Which equation could be used to find the lengths of the other sides of the triangle? All right. All right, so maybe for something like this, a lot of geometry questions, a diagram could be helpful. I don't. Let's make a right triangle. It won't be perfect, but good enough. Okay. Here's my right triangle. And this is not drawn to scale, but it'll help us keep it kind of organized. Okay, there's our right triangle. Here's my right angle. So they said the shortest side is 11 inches. The lengths of the other two sides, so this and this are going to be consecutive integers. So I'm going to call this longest side the hypotenuse x. So what would this be? Well, whatever this is, it has to be right, like the number just less than this. So we can call this x minus 1. So then I can think of the Pythagorean theorem, right, which is the side square, the leg square, excuse me, plus the leg square equals the hypotenuse square, right? The way we did in class this year was we drew these area squares. Forgive my poor drawing. It's more of a side rectangle, but whatever. So this area, this side square, so 11 square plus all of this squared is going to equal the hypotenuse square. And if I look at my answers, that looks to be D. Okay. 38, we don't have to do. They don't have recursion anymore. Very fascinating, but thankfully no longer on the test. Okay, last two questions, 39 and 40. Suppose x and y are real numbers. I don't think they cover this anymore actually either. If you're not sure, just think about some square roots, like the square root of 2, or whatever. Okay, these transformation ones. If you haven't done transforming functions, what's a good strategy? Oh, I can graph it. Yes, of course. All right. So g of x is 4 times x plus 5 squared plus 3. And the parent function is x squared plus 3. All right, so it's saying, and I'll zoom standard here in a minute. Okay. Now maybe that was a good one. We'll see. We'll see if I zoom standard, if it's too tight in. Okay, maybe not. So I always like to hit trace. Move around until I find my cursor. Where are you? Oh, there you are. Okay. So this narrower parabola is this one, is g of x. If I hit the up button, you'll see I go to the other parabola. I'll move that till it, okay. And this is f of x. So the graph of g of x is narrower and shifted 5 units. Well, g of x is definitely narrower, right? You can see there's like this and this. So g of x is narrower. So let's go to our answers for a sec. Okay, g of x is wider. G of x is wider. Okay, ditch those two. Focus. Okay. Oh, I can get rid of that. And then I can see that it's been moved over. You see they took this. Sorry. There, they took this x squared plus 3, which was f of x, and it looks like they slid it over. So it's narrower and shifted 5 units left. Hey. There you go. That's the test. So remember, you have 2 hours to do it. And I think you should leave yourself at least like 20 minutes, some strategies. Final thing, strategies for the test. You want to move at a good pace without rushing. So I think I can average, just doesn't mean everyone, but 2 minutes per multiple choice, maybe 2.5. But that'll give you enough time to go back and review stuff, and then up to 10 minutes for the big constructive response question. But you're not going to pass this test if you don't finish. So it really is important that you go home and bang this thing out and really be comfortable doing it in 2 hours. If you're not sure about something, don't sit there staring at it. Just circle it and come back. And at the end, you can make educated guesses, whatever. But you got to really meaningfully attempt to solve all of these questions if you're going to pass the test. So you can make tables to see how things are changing, and then evaluate, like if they, with the exponential functions, if it says doubling, it's kind of easy to make a table that shows something doubling, and then plug stuff in and see if it matches what you think should happen based on your table. So table helps. Plugging stuff in, plugging in to our equation, and kind of evaluating what's happening can be helpful. Right, use the calculator. So you should be comfortable next week with like these things, using the table, how to find an intersection, how to find a min or max for a parabola, how to evaluate for a value, trying to think what else, like zoom features, if you aren't sure about some of these, you're like, oh, I watched Mr. Gerard or Miss Youngblood or Mr. Rosser do this, and it doesn't make sense. Talk to them; they'll help you with it, but it's important. Zoom features, right? Like standard, out, etc. How to reset the calculator in case it freezes. Reset the RAM. And this is just like as an aside, I think parentheses are your friend. So make sure you don't make a mistake because you got sloppy with the calculator. Intersection, min-max, what other ones? Value, zeros. Min-max, intersection. I think that just about covers it. I think that's it. All right, I think that is everything. If you have questions, see your teachers. Good luck next week. You'll do great. Just remember, you want to move at a good pace without rushing. So, like a digital clock, like a watch with a stop timer, I can be able, just so you know how much time you have. Good luck on the tests. Yeah, good luck this weekend. Oh, I guess I'm supposed to say hit the like and subscribe button to things or to my YouTube channel. I don't know what that means.